Hello everyone, this is a November 14 question, paper 1-1 and the question number is 23. This question is concerned with an introduction to organic chemistry. The question reads, considering only structural isomers, what is the number of alcohols of each type with the formula C5H12O? Question says only structural isomers, so we should rule out optical isomers because stereoisomerism. From stereoisomerism, cis trans is not possible for this structure because we cannot have carbon-carbon double bond. So we are excluding optical isomers. What is the number of alcohols with each type with formula C5H12O? We need to deduce all primary, secondary, and tertiary structures of this formula. Now, this question is best solved by trial and error method, where you have to where you draw all the possible structures in the same question paper. Now, we are going to solve this by the same approach. First of all, let's check we can have straight chain carbon atoms or branch chain carbon atoms. First of all, let's finish all the straight chain carbon atoms. The first carbon atom that comes to our mind at best is CH3, CH2, 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 CH2OH. So this is our primary alcohol because this carbon has OH and it is attached to only one other carbon. Let's kind of make a table here: primary, secondary, tertiary. So primary has 1. Another is we could have this OH here, which is CH3, CH2, CH2, CHOH and CH3. Let's count the number of hydrogens: 1 2 3 4 5 6 7 8 9 10 11 12 1 2 3 4 5 carbon atoms, 1 oxygen. So this is our secondary alcohol. Its name is pentane 1-ol. Its name is 2-methyl butane. Its name, sorry, not methyl. Its name is pentane 2-ol, and we could also draw pentane 3-ol, which would be CH3, CH2, CHOH, CH2, CH3. So this is pentane 3-ol. Now we cannot have OH over here because pentane 4-ol and pentane 2-ol means the same thing. Same goes for this. So these are our straight chain carbon atoms, straight chain isomers. Now let's see the branch chain isomers. The branch chain isomer, the first we can have is carbon atoms arranged like this, which is 2, methyl propane 1-ol, I guess, probably, because if we add OH here, this will be 2, 2 methyl, 2, 2 dimethyl, sorry, 2, 2, because position this is 1 2 dimethyl propane 1-ol. We count from the lowest side. Propane 1-ol, this is our primary alcohol because this carbon has alcohol, primary alcohol 1, and this is also secondary alcohol. Now we can have, if we add OH here, making this CH3, this means the same thing. In the first one which we considered, we took this as the longest carbon chain. Now for this case, this is going to be, these 3 carbon are going to be the longest chain, and we are going to exclude this and this, which means again 2, 2 dimethyl. So from this typical structure, we can have only one primary alcohol. Another branch chain isomer we can construct is 1 2 3 4, and carbon can come here. Now the possible structures for this typical pattern is OH here, all surrounded by hydrogen, 1 2 3 4 5 6 7 8 9 10 11 12. So 12 hydrogen, and this is going to be our primary alcohol. We have 3 primary alcohols thus far. We can also construct this 1 2 3 4 5 and OH here. OH here means this is going to be tertiary alcohol because this carbon has OH group and it is connected to 3 other carbon atoms, tertiary 1. Now another structure for this same pattern would be 1 2 3 4 carbon here. We already had 1 here, adding OH here, and here is the same thing, because if we for this case we consider this as the longest carbon chain, considering this as the methyl group, and now for this we'll consider this as the longest carbon chain, considering this as methyl group. So this is 2 methyl butane 1-ol, and again this is also going to be 2 methyl butane 1-ol because 1 2 methyl butane 1-ol. So these two are the same thing. We cannot add to our tally here. Another structure is 1 2 3 4 5, and then we can have OH here, because this is going to be 2-methyl butane 3-ol, because we're going from here to here, from right to left. If we go from left to right, we'll have 3-methyl butane 2-ol, which is the same thing as 2-methyl butane 3-ol, because adding 2 and 3 gives 5 on both the cases. So we'll add, this is our secondary alcohol, carbon atom to 2 surrounding carbon atoms, added 1 to secondary. Now let's see if we can construct any more. We could also have this 1 2 3 4 5. Sorry, this is quite cramped. We can have alcohol here, and adding alcohol here is not the same as adding alcohol here, because adding alcohol here in this position, sorry about that, in this position it is 2-methyl butane 1-ol. In this case it is 2-methyl butane 4-ol, or 2-methyl butane 4-ol, or 1 2 3 3-methyl butane 1-ol. Yeah, 3-methyl butane 1-ol is the correct one, because 3 and 1 gives 4, and 2 and 4 would give 6. So this is 3-methyl butane 1-ol, and this is a primary alcohol. Added primary we have 4 thus far, secondary 3, and tertiary 1. Let's see if we can rule out any options. Option A rules out because it's only 3 primary alcohols. Options B and D also rule out because they only have 3 secondary alcohols. So by default and by process of elimination, our correct choice is answer C.